We're also going to take a look at the sum of interior, inside angles of polygons. So I can find the sum of interior angles of any polygon. So first we need to get what is a polygon. A polygon is a closed, straight-sided figure that has no lines that cross. A regular polygon, a lot of people always want to think they're like pentagons, those are regular. Oops. What a regular polygon would mean is all the sides are the same length. All of the sides are congruent. An irregular polygon then would have all different lengths of sides. So let's see what you can do. I need you to take your notebook and up here along the red line I want you to write number of sides. Then I want you to write polygons, draw a line down, number of triangles, draw a line down, and sum of interior angles. What you're going to do, you don't have to make this box. Then I want you to go 3, 4, 5, 6, 7, 8, 9, 10, and the letter N. A three-sided figure would be a triangle. A four-sided figure is a a quadrilateral. A five-side is a pentagon. Six-side is a hexagon. 7, a heptagon. 8, an octagon. 9, a nonagon. 10, a decagon. So hexa, hepta, penta, those are all numbers. They're prefixes for numbers. N is missing its prefix, so it's enagon. You're going to log into iExcel, take about 3 minutes on CC1, and just see what you know about polygons, and then come back to the video. All right, polygons can be cut into triangles to find the total angles of their sums. Remember, we know a triangle is 180. So if I have these shapes, we know a triangle is 180 degrees. So if I took this angle plus this angle plus this angle, we know that's 180 degrees. So if we can take any shape and we start cutting it into triangles, we can find out the sum of each of these angles inside. Now people want to start cutting. How you have to do it is in an organized way. You start from one vertex. If I go from here to here, that would not make a triangle. But if I go straight across, there's one triangle. There's a second triangle. There's a third triangle. Whoa. Whoa. That's crazy. And there should be a fourth triangle. Okay. From here to here. So you can see 1, 2, 3, 4, 5 triangles. So if you take 5 times 180, you would get, well, 5 times 0 is 40, would be 900 degrees. So this angle plus this angle plus this angle plus this one plus this one plus this one and plus this one, all those angles would match up to be 900 degrees. So let's look at this one. If we start at any vertex, it doesn't matter which vertex you want to start at. I'm going to start here. This to here is not a triangle, but here to here is a triangle. Here to here is not. So we have 1, 2. 2 triangles, both of them are 180, so it's 360 degrees. And this works for any shape that you want to try. So let's go back, to our diagram here. We know a triangle would have one triangle inside of it, and it equals 180 degrees. We know that. The sum of the triangles, if I add them together, equal 180 degrees. So let's look at a quadrilateral. All quadrilaterals have 4 sides, which means if I cut them in half, they would create 2 triangles, which would give me 360 degrees. A pentagon, if I cut a pentagon up, I would end up with 3 triangles. And that would give me 540 degrees. Basically, I've added another triangle, so I've added another 180 degrees. Hexagon, one more side, would then add one more triangle, which would give me 720 degrees. We did a heptagon. We did a 7-sided figure, which gave me 5 triangles, which would give me 900 degrees. So hopefully you're starting to see a pattern. Let's finish our table and then we'll look at the pattern. So you should be able to list these down. Okay, so we know an octagon had 6 triangles, which would be 1080. And a nonagon, which had 7 triangles, would be 1260. And a decagon would be 1440 degrees. So again, what we did is we are taking the number of triangles and we're timesing them by 180 degrees. And that's how we found them out. Well, how are we going to find out if we don't know the number of sides in a nonagon? Let's go back to our drawing here for a second and let's look at these. If this has 5 triangles in it, it has 1, 2, 3, 4, 5, 6, 7 sides, and it has 5 triangles. This one has 1, 2, 3, 4, and one has 2 triangles because we took 180. So you should notice that there's always 2 less. So in this case, if we count the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it means it should have 8 triangles. Let's test it out. If I'm going from here to here, I don't count it. There's 1, 2, 3, 4, 5, 6, 7, 8 triangles. Sorry to make it such a mess. 8 triangles. So 10-sided figures had 8 triangles. So what we're ending up doing with our nonagons is we actually are taking the number of sides and minusing 2. 8 minus 2. 10 minus 2 got me 8. So in a nonagon, in an anagon, we would take the number of sides minus 2 to get the number of triangles and times 180. So any sum of interior angles, the formula for the sum of interior angles equals, they put the 180 times n minus 2 is usually the way it's seen. So go ahead and get started on your worksheet.